All right, class. Good evening. Let's begin the class. So in the last class, we had started with magnetic Lorentz force. Magnetic Lorentz force was what? QV cross B. And here, based on sine theta, QVB sine theta is QV cross B. Based on QVB sine theta, we have various values. We have four cases. First case was if B and V both are parallel, that is making an angle of 0 degree. So force is what? 0. If it is anti-parallel, means making an angle of 180 degree, still your force will be what? Force will be still 0. So parallel ho ya anti-parallel. Both the cases, magnetic force will come out to be 0. Okay? Now, in the third case, we had seen that if the particle was moving perpendicularly to the magnetic field was moving inwards or outwards, but your charge was moving along the page. So this showed what? Your particle is perpendicular to the magnetic field. So if your particle is perpendicular to the magnetic field, as I've told you, this is a very important case. Most of the questions from your Lorentz force come from this only. Here R was mv by qb because necessary amount of centripetal force was provided. Last case was left. Let's just quickly complete the last case. These questions, I think I have given you these questions in the assignments also. Just check it once. Now, if 0 degree, we have seen, 180 degree, we have seen. Now, if the particle is at an angle, koi bhi angle hai, it's a random angle. The random angle that has been formed. It's a random angle that has been formed. So let's say charge is there. Charge is making a random angle over here. We do not know whether it's 0 degree, 180 degree. We do not know which angle is this, but for sure we know it's not 0 degree. This angle is not 180 degree. And this angle is not 90 degree. Why? Because had it been any of these angles, we know what's the answer. For 0, 180, it will be 0, 90 degree. We have already seen the case. Here, what will happen? See, we have to resolve the velocities. We'll resolve the velocities. So the velocity component, this is V velocity. It can be 60 degree. Yes, Fahad, it can be 60 degree. It can be any value. But for how much values will you remember? 0 degree, you can remember. 180, you can remember. 90 degree, you can remember. But kahan tak yaad rakhoge? How much can you remember? You have to have a finite value only, because angles are till 360 degree. The complete angle is 360 degree. So if it's a random angle, you will solve it by f is equal to qvb sine theta only. Here what will happen, if you resolve the velocity, the angle with the axis with which the angle has been made, that becomes cos theta. So this is v cos theta, this is v sine theta. Notice I have written parallel sign over here and I have written perpendicular sign. What happened is that this parallel sign that you're able to observe, this gives motion in a straight line, means your charge is able to move forward. Your charge is able to move forward. See, because of V parallel will do what? Your charge is here, your charge will move like this. This will be because of V cos theta, that is V parallel. And because of V perpendicular, this motion will occur. So if you combine both of these, what will it be? It is moving forward also, it's moving in a circle. Then it's moving forward, it's moving in a circle. Forward circle. This path becomes, we call this as helix. This is known as helix. This is known as a helix. So helical pathway obtained. So if it is at random angle, which is neither 0 nor 180 or any of these, it's a random angle, QVB sine theta will give you magnitude. But what about the path of the particle? So it will be helical. The path will be helical. Reason for that is because the motion is occurring forward also, and the motion is occurring in a curved manner also. So combined action becomes helical. This was the fourth case. So if the fourth case comes, no, you just have to write about V perpendicular, V parallel, and you just have to write this much. Path will be combination of circular motion and straight motion, straight line. That it would be a helical. This much is enough to write. Fine. So just note down this last case that was left to complete in the last class. So all the 4 cases we have seen, this is the path of the particle, a charged particle in a magnetic field. Now we'll see what is the path if it is kept in an electric field. Yes, Darshan, I'll show you the other cases also. First 2 cases are very easy. Just take the screenshot, Darshan. After the class, you can copy it down. First case is this. See, QVB sine theta is the force. So for all these 4 cases come. The first 2 is very easy. You will be able to do. Take the screenshots quickly, Darshan. Chapter notes after. Okay, Darshan. I'll share. Chapter notes. Notes I'll share with you if I have the notes. Derivations at least I can share it with you. Rest of the things which wherever you're having issues, no, you can ask. So did you take the screenshot? No, first only you have taken, no? Second is this. This class notes means this one, which you have missed. This magnetic Lorentz force. You're asking about this class. Okay, Darshan, I'll do one thing regarding this chapter. No, I'll share the video playlist with you. Then what you can do, you can skip it up, skip the portion, or whichever portion you want to see, you can watch the part of it. And then what you can do, note it down or take the screenshots, whatever is suitable for you. Because sharing this is a little bit difficult. I do not have the notes with me separately. So if I'll share you the playlist now, you can easily take the screenshots from this part, whichever part you want to see, whichever portion you have to see. I'll share the playlist of this batch. So do you want to note down anything right now, take the screenshot, anything, or should I show you the case 4? Done. All right. If particle is perpendicular, this is it. This is the direction of the force that we were concluding using our right hand thumb rule. So basically motion of the particle is circular. Third case is motion of the particle becomes circular. Fourth case is motion of the particle becomes helical. So this is the radius, and at least till here you just take the readings and note down the notes, Darshan. The rest of the things you can note it from the video.
I mean, the 4th case, there's no any formula, right? And any equation.
No equation, no formula. Formula is F is equal to QVB sine theta. So whatever angle is given, you can write. We are discussing here what will be the path of the charged particle. So in the first case, it's parallel. Second case is it's anti-parallel. Third case, it's a circle. Fourth case is helical. Regarding the magnitude, first, second, third, you know. Fourth case, any angle can be given. So F is equal to QVB, you can consider. And one more thing, that's good, Fahad has reminded. In these formula now about the radius and of the time period, the velocity that will be, it will be V perpendicular. Out of these two velocity, which velocity you should consider? So remember, you have to consider this V perpendicular. And in time period, you do not have any relation between velocity or radius. This question is also important, especially in your NEET exam. This question comes a lot. How is the time dependent on the radius and velocity? And 4 options will be given: directly, independent, inversely, like this. So time is independent of radius and velocity. Questions will come in this manner, Fahad, that see, first two cases are very easy. So those questions do not come because angle is 0 or 180-degree. Question will be describe the path of a charged particle when the charged particle is moving perpendicular to the magnetic field. So you will explain the whole third case that force is directed towards the center, centripetal force will act, means this will provide you the right necessary amount of centripetal force and everything. This way it can occur. Or it can come in this form, the radius, that formula that we did, and the type of questions, numericals we have done. Regarding the fourth case, it will ask you if a charged particle is moving at a random angle, what will be the motion of the charged particle? So you will describe it that the motion will be helical. Why? You will describe about the V perpendicular, V parallel. No numerical will come because numerical comes from the initial part only that we have covered in the last class. F is equal to QVB sine theta.
That third point is important. Third case.
Third, and even the fourth case, this comes for 2 marker or 3 marker. But third case is very important, more than this. So done. Now we'll see one more thing. See, magnetic Lorentz force we have done. But when it's just Lorentz force, it means when magnetic field is also there, electric field is also there. We have seen the path of the charged particle when it is kept where? When it is kept in just magnetic field. What if electric field also exists and a magnetic field is also there? So see, for electric field, we know it's charge multiplied by the electric field, QE. This we have studied in the first chapter itself. F is equal to QE. This is the electric force, magnitude of electric force. What did we study now? Magnetic force was what? Magnetic force was QVB. This is what? QVB, or let's write V cross. QV cross B is there. QV cross. So this is what? This is electric force. Because electric field exists, so obviously electric force will come into action. Magnetic field exists, so we will be having magnetic force as well. Now, the resultant Lorentz force that you will get this time. See, I'm not mentioning magnetic Lorentz force. I'm just saying Lorentz force because it's not only the magnetic component that has occurred. So the net force that will occur will be QE plus QV cross B. Means it is actually what? This is sum of the electric force plus plus the magnetic force, sum of electric and magnetic force. This that you obtain is known as Lorentz force. This was just magnetic Lorentz force. This is electric force. And this combined is magnetic Lorentz force. This combined is Lorentz force. So you can write it in this manner also. Q you can take common. E plus V cross B you can write. This much newtons. This is what is meant by Lorentz force. This is also, this question numericals do come from here. Now regarding the direction of electric force. Electric force direction is what? Whatever is the, if it's a positive charge, so direction of force is same as that of electric field. If it's a negative charge, then direction of force is opposite to that of electric field. Why are we discussing this right now? Just to as a revision. Direction of electric force we have studied in chapter 1. If it's a positive charge, force and electric field are in same direction. If it's a negative charge, force and electric field, these are in opposite direction. Basically, electric field's direction remains fixed and direction of force depends upon the nature of the charge. This is just a revision. This you all have studied. And you also have studied the direction regarding the magnetic force using your right hand thumb rule. So if it individually comes, so you can easily predict the direction of electric force, you can say direction of magnetic force also. In the last class we had studied the direction of magnetic force, right hand thumb rule, that only will be applied over here. Now one question, I think just note down this part, then we can do the question after. First note down this part. Any doubts from here? Is this clear? Wafia, Zaid, Sahal, clear to all of you?
Yes, ma'am. Clear.
From this portion, most of the time, numericals only come. Electric field will be given, magnetic field will be given, charges value will be given, or it will say an electron. So charge also you have to write on your own, like this. Maximum time, it's the numerical that comes. So Lorentz force is what? If charge particle is moving in a region that is having both magnetic field as well as electric field, then it may experience both electric and magnetic forces. Yes, yes. E is the electric field. E is the electric field. Q is the charge. V is the velocity. B is the magnetic field.
So E plus V into B.
Yes, Fahad?
Am I audible, ma'am?
Yes, yes, Fahad. Say.
Yes, I was saying, ma'am, in the formula, sorry, in the question, we have to use this one Q E plus V into B.
Yes, if you see in the question, no, electric field's value is given and magnetic field's value is given, then you use this formula. If you see only magnetic field is given, so understand that it means it's not a case of Lorentz force, it's just a case of magnetic Lorentz force. So if electric field and magnetic field both are given, directly use this formula. F is equal to E plus V cross B. V cross B you can solve it, VB sine theta. Then add the term with electric field multiplied by the charge.
Ma'am, what is N here? N.
N is Newton. Force is SI unit. Newton.
Okay. So,
Try this numerical. Value of velocity is given, charge is given as 2 coulomb, electric field is given, magnetic field is given. And V cross B now you have to do in Cartesian form. Angle is not given, so VB sine theta will not be valid. It will be V cross B. So you have to form the determinant system and then do. The way we solve two vectors, cross product of two vectors in Cartesian form. Yes, Darshan, I'm telling. See, charge value is what? Charge is 2 coulomb. Electric field is given as 2 I cap minus 3 J cap, Newton per coulomb. Velocity is I cap minus 2 J cap. Magnetic field is what? I cap minus J cap minus 5 K cap. Whoever can solve, try to give me the answer in the chat box. Now we have to, our equation is what? Net force is what? Net force is Q E plus V cross V. That's what we have studied right now. So let us first solve V cross V. Cross product of two vectors in Cartesian form is solved in this manner. We have discussed though this a lot of time, but students who were not there, we can discuss it again. You have to write I cap, J cap, K cap in the form of a determinant system. In maths, you people study these determinants and all in detail. So first vector is what? Velocity. Write the coefficient of I cap, it's 1. Then write the coefficient of J cap, it's -2. Coefficient of K cap, nothing is mentioned, so it will be 0. Vector B, coefficient of I cap, it's 1. Coefficient of J cap, it's -1. Coefficient of K cap, it's -5. So V cross B will be equal to, first we'll write I cap. Now when you write I cap, you ignore this row and this column. And first cross multiply these minus cross multiplication of these. So -2 -5 will give 10, minus -1 into 0 will give 0. This has been solved. Now, when we write J cap, for case of J cap, we always write minus J cap. I cap we write plus, K cap we write plus, for J cap we write minus. Now, when we are discussing J cap, ignore this row and ignore the J cap. Whichever row you are considering, whichever unit vector you are considering, ignore that. Now see, cross multiplication of this minus cross multiplication of this. So this is 1 into -5 will give you -5, minus 1 into 0 will give you 0, plus K cap. Determinant step, yes. See, Darshan, here first what do you have to do? You have to write ijk cap. Whichever vector is first, write its coefficient. Whichever vector is second, write its coefficient. Fine. Till here, I hope it's clear how to form this, how to make this.
Ma'am, can you explain it one more time? Writing that values in the determinant.
Values in the determinant. See, coefficients, you know, it's what? I cap minus 2j cap. So coefficient of I cap is what? 1. So you will write 1 under this. Then coefficient of j cap is what? It's -2. So you will write -2 under j cap. Whichever vector is first, now the way you calculate torque. Torque is r cross f. So first you will write r first, then force. Similarly, here it's v cross b. So you will write v first, then you will write coefficients of b. Here nothing is mentioned. This means this is plus 0 k cap. That's why nothing has been mentioned. So 0 here. Coefficient of I cap, coefficient of J cap, coefficient of K cap, all these three are written. Fahad, tell me, is it clear till this step first?
Yes, ma'am, now it's clear.
Now it's clear. Now see, for this no, remember I cap is written positive, J cap is written negative, K cap is written positive. You can write J cap also positive, this portion, then that you have to reverse, but let's do it in this manner. Now, what are the coefficients now that you will write for I, for J, for K? So see, whichever unit vector you are considering, let's talk about I cap. So see, ignore this, cut the I row, cut the J, this whole row. What are we left with? We are left with these four, -2, 0, -1, -5. We do cross multiplication of the first term. That is what? -2 into -5. Cross multiplication of first term minus cross multiplication of second term. And in this manner only you will go. First this, second this, then this, like this only. So second term is what? -1 into 0. Look here, Darshan. -2 into -5 will give you +10. So that's why I've written +10 over here. -1 into 0 will give me 0. So that's why I have written 0 over here. Then so I have received the coefficients of I cap here in the answer. First tell me, anyone, Fahad, Darshan, Abia, Madiha, anyone who is having doubts. Is it clear till here how to write the coefficients of I cap in the answer? Clear, Darshan, what about you? Which line? If it's possible, Darshan, you can unmute yourself. Okay, avoiding the two lines. These, no. See, I cap, J cap, K cap is of no use right now. So just cut it. Ignore it. When you will ignore this, no, then only you will be able to see these four. And right now we are finding out first the coefficient of I cap. So entire row of I cap, you cut it. Fine. If you cut this row, you cut this row, you are able to, you don't need not to cut it. Cut it means what? Just avoid it. You just have to focus on these four right now. Cross multiplication and this one. Now minus J cap. Now we'll see J cap. First row, first column. Yes. First row, first column for I cap. Now let's see it for J cap. You can draw it again. All right. So see, this was -5. This was done. Now we are focusing on what? Solve it, Sahal. You have got, just multiply it in the brackets.
I can multiply
You can
it?
multiply. Yes. Within the bracket, you can multiply 2.
Okay.
At least you can multiply. Leave your answer in terms of I, J, K cap. That's okay.
Okay.
Yes, Darshan. I'm writing answer. I'm writing down the answer. Then now what did we have? We had J cap. So we eliminated the J cap and the entire row of J cap. Whichever you are focusing, no, and eliminate that. So when we eliminated this, we got 1 into -5 and -1 into 0. That's how we received this. Now we are talking about K cap. So as I've told you, this is of no use to you, this row. But now we are focusing on K cap. So cut the row of K cap. Whichever universal unit vector you are focusing, cut that row. What are you left with? You are left with these four. Again, cross multiplication of this minus cross multiplication of this. So 1 into -1 will give you what? 1 into -1 will give you -1. So this done, put a negative sign. Then cross multiply these two. -2 into 1 gives you -2. This is what we are left with. So what are we left with? Now tell me, any doubts in any of the part? How to write the coefficient of I, J, K, any of these? Because after here, the part is easy. This is your cross product. Now you just have to write it. This becomes 10 I cap. This is -5 into -j. That gives you +5j cap. And this is what? -1 plus 2. So 2 minus 1 is 1. That is K cap. So this is what? This we have obtained. That is V cross B. What was it? V cross B plus electric field. Remember? Here we have now found this. Now we have to add electric field. Electric field is what? 2I cap minus 3J cap. So electric field. Add electric field to V cross B. I cap, J cap, K cap, Sahal. That also.
That is there in the,
That is there. All right. So now E is what? E was, I think, 2I cap minus something J cap, no? 2I cap minus 3J cap. Fine. 2I cap minus 3J cap. This is electric field plus. What is V cross B? V cross B is this term. 10I cap plus 5J cap plus K cap. So what's the answer for E plus V cross B? 2I cap plus 10I cap. That gives 12I cap minus 3J cap plus 5J cap. That gives plus 2J cap. K cap is not here. K cap, only K cap is there. So plus K cap. what was the last step? Q multiplied by this, E plus V cross V. So charge is 2 coulombs. If charge is 2 coulombs, if charge is 2 coulomb, then you just have to multiply this by 2. So your net force will be what? 2 into 12 I cap plus 2 J cap plus K cap. So your answer becomes 24 I cap plus 4 J cap plus 2 K cap. This much amount of Newton. Like this you have to solve. This is the most difficult question that can be possible. Hopefully in your exams, if direct values are given, your answer becomes easier. So I think Sahal has got the right answer. 24 plus 4 plus 2. Initially you were getting minus 3 K cap, Sahal.
Slight mistake, ma'am, but then I
Right.
rectified it.
All right. So write down the solution. Rest of you, wherever step you're not able to understand, ask me. See, force between parallel conductors are left, then torque, and then one more topic is left. Torque is left, magnetic dipole. So I think 2 to 3 classes will be needed for the completion. Yes, Darshan, there will be extra classes also because your half yearlies will be approaching. Tell me one thing, class. Do you people know when are your half yearlies going to start? Or are you aware of your syllabus? 11 September, your half yearlies are starting or your school is reopening? Okay, half
School is reopening on September
September which? 5th, 4th?
6th, I guess.
6th. All right. Yours. Zaid, last of September. Year 9. All right. Just let me know when is your physics exam? All of you. Whenever is your physics exam? All those who are aware of and who have the knowledge about their schedule. And also let me know the syllabus. How much is it coming? And Darshan, syllabus, how many lessons are coming? So done, class. A small topic is left.
Yes, done.
See, a very small topic is left. This is also important. Force on current carrying conductor in a magnetic field. It's a very small topic, but what happens from this? No, this is helpful in the calculation of other. 4th unit, first book. 4th means the first 4 chapters there. Okay, the whole first book is coming. All right. And Darshan, chapter 1, electric charges in field, electric potential, current, electricity, moving charges. Fine, Darshan, for you the lesson will be over. For you will have all the lessons. I'll give you the revision classes also. Revision classes we'll be having. That's why I wanted everyone, at least if you, all those who can tell me by the next class, do tell me about your syllabus status. So Darshan, for you it's not a problem. Till EMI and EC, no? Okay, EM waves is excluded for Z. Fine. So fine, Z, you will also be able to manage it because this was the major lesson. Once this lesson gets over, no, then your syllabus will speed up. Now, if a charge is there, a charge particle is there, there's a conductor. L is the length of this conductor. And let's say this is a positive charge or it can be negative charge. So let's take it as an electron. So if this is the flow of charge, current will be in opposite direction. A is the area of the cross section of this conductor. I is the direction of current. N is the number density of electron. Number density means electrons per unit volume. So L is the length of conductor. A is the area of cross section. Now volume of conductor will be what? If length is L, area is A. So volume of conductor, that becomes simply A into L. Volume of conductor is A into L. So total electrons will be what? Total electrons will be number density of electrons into the volume. If for a unit volume, electron is 1. So for the entire length, it will be just volume multiplied by the electronic charge. And right now we have studied that net force is what? Minus E Vd into B. So put the value of total electron. Total force on all electrons will be what? Total force on all electrons. This is the force on a single electron. Right now we have studied this. So total force on all the electrons. This will be what? Instead of E, this becomes NEAL VD into B. I'm writing negative sign just to show that this is an electron, a negative charge is there. Now, if we just interchange something, if you just interchange over here, NEA, just make drift velocity outside, put current, this length of the conductor in the bracket. Can anyone tell this quantity? Yes, someone was answering. Fahad. Anyone? NEAVD. You had a test also of this.
It is the current, right?
Current. Yes, NEAVD. Forgotten this. I is equal to NEAVD, where VD is what? VD was your drift velocity. VD was the drift velocity. So here, what is the final formula? Final formula is I L cross B. So many a times this is written as BIL also. This force is written as BIL. So easy questions are there. See, this question says what? This question says 5 ampere of current is flowing. Length is 10 meters. Magnetic field is 2 Tesla. So this is showing magnetic field is inwards. You have to tell the magnitude and direction of force. So magnitude will be what? See, length of the conductor is 10 meters. Current that is flowing is 5 amperes. Magnetic field that is there is 2 Tesla. So force will be BIL. Even if you take L cross B, that will be LB sine theta. And the angle between the length of the conductor and magnetic field is 90 degree. So that will be sine 90 is 1. So you can directly write BIL. So this becomes 2 into 5 into 10. Right? 5 into 10. Yes, this is 100 Newton. Regarding the direction, see, keep your hand along the direction of current. If you curl your fingers are leading inwards. So thumb is pointing downwards. So that becomes the direction of force, downwards. Downwards you can write, or minus J cap you can write this way. Or one more question, let's see. See here, this question. Here the magnetic field is pointing outwards. Magnetic field is pointing outwards, but the angle between the length of conductor and magnetic field is still 90 degree. Theta is still 90 degree. So you can use the value of force as BIL. So B is 2, current is 5, length is 10. That is 100 Newton. But direction, if you keep your hand along the direction of current, curl the finger outwards. This time your palm will be facing your face. This time your palm will be facing your face because the current is going upwards. Then you will curl the fingers towards you. Thumb is leading where? If you will curl it, thumb will lead rightwards, towards the right. That will be I cap. For the first part also, let's check it. Just 1 second. I think direction will be something else. Because if you curl it, it will be upwards, not downwards. See, this will be upwards. Why? First one, yes. First will be upwards. First one will be upwards. First one, this will be upwards. That is your J cap. Because see, if you keep your right hand towards the direction, no. So the dorsum of your hand means the back side of your hand will be facing you. Palm will be facing the screen or the notebook, wherever these have been drawn. Then you will curl the fingers towards the sheet, towards the magnetic field. Thumb will be upwards. And in the second case, the ventral side of the hand, that is the palm, will face towards you. And so that fingers will be curled towards you. So thumb will point towards the right hand side. That is your I cap. So this is a short topic. Derivation can come. Derivation is not so important, but f is equal to BIL is used a lot. In other derivations also you will be observing this. F is equal to BIL. All right, note it down from you.
Ma'am, instead of writing J cap, I cap, can we just write upwards, downwards, or inwards?
Yes, you can write upward, downwards, inwards. It's just that when we did combination of all these magnetic fields, there we had to add all the different magnetic fields. When we combined all the figures, semicircle got added with a wire and all these. So what happened? We combined all of these. So when you combine these figures, no, remember we did it for the circular axis also we did. So when you combine all the figures, what happened? I cap, J cap, K cap, calculation becomes easier. So that time you can consider, otherwise you can leave in terms of outwards, inwards, right? Like in these questions, nothing was added, only one force was there. So you can leave that way also. But if in the question it's a combination, so how will you get your final answer? You cannot add a magnetic field that is pointing outwards with a magnetic field that is pointing towards the right negative x-axis. For that time, for those questions, you require I cap, J cap. For the second one, Fahad, magnetic field is outward. Magnetic field is outward, but current, the direction of the magnetic force that is occurring. So magnetic force is towards the right. Magnetic field is outwards. That's why you get your thumb pointing towards the right. Just text done when you have written, all of you. Just one small last topic is left. Numericals we'll do in the next class only of that topic. But just one small topic is left that we'll do. Bafia, you're able to understand?
Yes, ma'am.
Now see, for a single wire, we have calculated what's the force. What if two parallel wires are there? Then what will be the force? So this is easy, but the derivation also comes. To prove the force between two parallel wires, to prove the force per unit length for two parallel wires. So this derivation is important and the numericals are also important. These questions come in the exam. But numericals part, that we'll do in the next class only. Right now, we'll focus on the derivation. So see, this is one conductor, this is one conductor. Two wires are there, these are parallel to each other. First one is carrying the current I1, second one is carrying the current I2. Both are pointing, the currents are in the same direction. L is the length of the conductors and the separation between the conductors is small d. Now, magnetic field for the first one. Remember when we started the lesson, when we were doing the applications of Biot-Savart's law? You have a test also today. So there also, that will be helpful there also. Magnetic field for an infinite wires was what? These are parallel wires, but these are long wires. Long wires means these are infinite wires. For long wires, anybody remembers the formula? You have the test also. The formula for long wires, infinite long wires. One we did as semi-infinite, other we did as infinite.
U
Yes,
naught
sir.
I by 2 pi.
2 pi.
Right.
Yes, right. ठीक. B is equal to mu naught. Now for the first conductor, magnetic field will be mu naught I1 because it's due to this divided by 2 pi and the separation, that is T. We are calculating at this 2 because of 1. So here F21 means force on the second conductor due to the magnetic field of the first one. So in this formula, no, now you are aware of BIL sine theta. That's why we did it. Here the difference that comes in two conductors is that magnetic field is the first one. Magnetic field is not B2, I2, L and B2. We do not write B2 because it's the force that is occurring on the second conductor because of the magnetic field of the first. So you will write F21, this is equal to I2, L, B2, B1. Magnetic field is of the first conductor. Now just put in the value. F21 will be equal to what? F21 will be equal to I2, L. Instead of B1, you will write mu naught I1 divided by 2 pi D. So this becomes what? This is force on the second conductor due to the first one. Force on the second conductor due to the first one. So you can write this as mu naught I1, I2, L divided by 2 pi D. This is a formula. So this is the force on the second conductor with respect to the first one. Now, what if I divide this length? If I divide the L, see, if I divide the L over here, F21 will be what now? F21 divided by L. This L, if I transport, no, that becomes what? Mu naught I1, I2 divided by 2 pi D. So this formula is force per unit length. So be aware of the question, is it asking you only the force? So you have to multiply it by the length. If it is asking you force per unit length, so you just have to solve this much part. Now, if the two conductors have the current in the same direction, like this. Both the currents were in the same direction. Then the conductors have a tendency to attract one another. Conductors attract each other. If the currents in the wire are flowing in opposite direction, one is flowing in this, second one is flowing this is I1, this is I2, then the conductors repel each other. You have to remember these points. These are asked in combined questions regarding the direction. That we'll see in the next class, how the question goes. And obviously, if the force on second conductor with respect to the first one is F21, then negative of it will be force on the first conductor due to the second one. Here, magnetic field will be required of the second one. Here we had the magnetic field for the first one. One more thing that is asked in this is define 1 ampere. If it is asked, now define 1 ampere from this topic. See, for defining 1 ampere, if I put the value of I1, I2 as 1 ampere, fine. I am defining 1 ampere, so I'll put it as 1 ampere. Distance also I'm taking as 1 meter. See what is left. This is mu naught left, divided by 2 pi is left, because these terms are 1 now. Put the value of mu naught, 4 pi into 10 to the power minus 7 divided by 2 pi. What is the value of force that I'm obtaining? 2 into 10 to the power minus 7. So if the question comes, define 1 ampere for the force between two parallel conductors, means if it's 1 ampere from this section, usually 1 ampere is what? 1 ampere is 1 coulomb divided by 1 second. I is equal to Q by T. That you will do. But if the question is asked, to define 1 ampere, so 1 ampere is what? 1 ampere is basically that current that flows through two long conductors separated by 1 meter. See, the distance that we took was 1 meter. Produces force per unit length of 2 into 10 to the power minus 7. This was force per unit length. No, here we didn't include length. 2 into 10 to the power minus 7 Newton per meter, which can attract or repel each other. At least this much theory you all should know. Numerical questions we'll do in the next class only. Because I think all the topics, we have done a lot of topics today. So that,
in the question it comes define 1 ampere like this.
Yes, if the question comes define 1 ampere, normally if it is written, then define 1 ampere in terms of voltage and all those. 1 ampere is 1 volt per 1 ohm, 1 ampere is 1 coulomb per 1 second, however you want. Current electricity, that is current electricity. If it mentions you define 1 ampere for force between two parallel wires, then you have to mention, you have to define 1 ampere like this. It's the force of 2 into 10 to the power minus 7 Newton per coulomb, and 1 ampere flows through the separation between them, that is 1 meter. Then you have to write down this line as well. This line is not difficult. This line is basically this only. Explanation of this. 1 ampere current for separation 1 meter, that is 2 into 10 to the power minus 7. This comes for 2 markers, and this has come in the board exams. This comes in your school exams also, half yearly also. So this is the last topic. Just note down this. Then I'll not proceed with the numerical study. So that at least you'll get a 5 minutes break for the test, before the test. Yes, Darshan, in the group also I had reminded about the test. Remember others? Biot-Savart's law plus the application of Biot-Savart's law. On the group also I have written it. You are still not added on the group, Darshan. I'll get you added today. Fine, Darshan. So if just see the question paper, if you see you're not comfortable, then you can take the screenshot and do it as an assignment and submit me later on WhatsApp only. But let me get you first added on the WhatsApp. Or if you think you are able to solve the paper, you can attempt the test. But rest of you should give the test. A very small topic is there, not even a complete chapter is there. So all those who have written, you can take a 5 minutes break at 10:35 for me. After 5 minutes, I'll begin with the test. Darshan, just wait for 5 minutes. After 5 minutes, I'll just show you the paper. I'll show it together only.